If you're a JavaScript engineer looking to take a leap into blockchain development, you've come to the right place. Today, I'm going to take you through how to set up your own local development environment, how to use OpenZeppelin's contracts library so that you can bootstrap your first ERC20 token. And thirdly, we're going to deploy that token both to your local network as well as to the Sepolia test network so that you can see it live on the blockchain. Now, let's begin with the first basic question. How do we even set up a local development environment for smart contracts? To run our local environment, we're going to be using Hardhat. Hardhat is great if you're coming from a JavaScript or TypeScript background because it enables us to interact with our contracts, write deploy scripts, and test out our contracts directly using JavaScript and TypeScript. And it's quite similar to the type of frameworks we're used to working with in Node or even React and other front-end frameworks. So let's get started. I'm in my terminal, and the first thing that I want to do is create a folder. So I'm going to call this folder my token, and I want to move into it so that once I'm inside, I can start initializing my Hardhat project. Now, this is basically similar as to how you would imagine initializing any Node project. So it first asks me whether I want to do a JavaScript or TypeScript. I myself am a TypeScript girly, so that's what I'm going to go for. It asks me whether I want to have a git ignore. It's definitely a best practice to do so, as well as installing the dependencies that they're recommending for the Hardhat toolbox. Really, these are a variety of foundational packages that will just make your experience easier with things like testing, things like ethers for interacting with your contracts, deploy scripts, things like this. And once we're done, we're going to hop inside our code editor and let's take a look at what Hardhat initiated. So as you can see here, this is quite a similar structure as to how you would imagine it from a Node project. We have our contracts, we have our Node modules with their packages, we have scripts like our deploy scripts. We'll use this to deploy our contracts. We have tests, git ignore, the Hardhat config file, which we'll use to deploy and set up our networks, package.json, which is where we can find our dependencies, readme, and of course the tsconfig because I'm using TypeScript. So the first thing that we want to do now is make sure that we install our OpenZeppelin library of contracts as well as our .env package so that we can have environment variables inside of our project. And with that done, now let's take a look at how to implement OpenZeppelin contracts and start building our token. Now, one of the best ways to build our first ERC20 token is to leverage the battle-tested and safe OpenZeppelin contracts. And so what we're going to do today is that we're going to head over into their contract wizard, which is an interactive tool enabling us to leverage their contracts library directly from a few custom parameters. So as you can see, we can create a governor contract, which is for voting and having some type of governance mechanisms. We can leverage their real-world assets contracts to bring real-world assets on chain. We can build stable coins. We can do hybrid tokens, NFTs, or we can do what we're going to show you today, which is build our first ERC20 token. Now, I can set up my name. For example, I can create my own Joel's token. I can call it Parks. I can call it whatever I want. For the purpose of this exercise, let's just call it my token. I'm going to pre-mint to myself 1,000 tokens to kick things off. And I can set up some features. So I want my token to be mintable, to be burnable. I want to be able to pause and unpause my contract just in case my project stops or there's a security complication that I want to take a look at. I can set these up to be tokens with which you're able to vote, say on my governor contracts. So there's a lot of different parameters that you can do here just quite interactively. And the best way to learn how to use them is you want to go into the documentation of OpenZeppelin, dive into their contracts library, and you'll be able to see at a deeper dive all of their API documentation and learn how to use this for your own project. Now, once I'm done setting up my token, what I want to do is I'll copy paste that code and I'm going to head back into my cursor, my VS Code, your code editor of choice, and I'm going to create a contract. In this case, I'm going to call it my token.sol, and I'm just going to paste directly the contract that I just created in my contract wizard. Now, as you can see, a lot of what I'm doing here is importing from the OpenZeppelin contracts library and using that functionality directly within my contract. If we take a deeper look, I'm making my tokens burnable, I'm making them pausable, I'm making them ownable, which means that the owner is the only person who is able to pause, unpause, and mint. Now, once this is done, Congratulations! You've built your first ERC20 token and now it's time to launch it and deploy it to the blockchain. What we want to do is now take a look at scripts, and we see that Hardhat has already provided a deployment script for us. Now, of course, they're doing it with their law contracts that they provide as default, but we can still adapt this code and use it to deploy our own My token contract. So first, let's delete these parameters. And what we want to do is console log some changes so that we can see that directly within our terminal. So we're deploying the token contract, which is calling on ethers. Ethers is how we're connecting into our contract library. And in this case, rather than sharing the lock contract, we want to call the My token contract. And so, of course, let's change the name of our variable as well. Now, once we've already fetched the contract that we want to deploy, now it's time to actually deploy it. So we add in a little console log as well. We call this variable token. And now what we want to do is we want to connect to My token and deploy it by passing it the variables that we want as parameters. So if we take a look at our constructor function, we see that we need two parameters. One that will be the recipient of the initial 1,000 tokens, and another one which is the initial owner of this contract, which is the one that will be allowed to perform these functions. And so the best way to get those variables will be to just go into your wallet. In this case, I'm using Rainbow. And what we want to do here is tap into my wallet address, and I can then use that for my deployment. So I want to pass in the first address, which will be the recipient of the tokens, and then pass in the second address, which will be the owner. In this case, both are the same. And once that's done, then we want to wait for that contract to be deployed. And we're going to be sharing a little console log as well to show that that contract has been deployed. So we're going to head back into our terminal and see what happens when we run npx hardhat run scripts deploy. So we get an error saying the pragma statement file doesn't match the same compiler. And this is because our contract is requesting a Solidity version of 0.8.22, whereas our Hardhat config is compiling at version 0.17. So if we change this and we go back in and run our deploy script, then that should effectively deploy our token. Now, congratulations, this is the first deployment that we'll do today, but there's a problem with this one. And it's that currently Hardhat is deploying it into our own local environment, which means that if we go into Ethereum or Etherscan, Sepolia scan, we won't actually see our contract being deployed there. And so what we want to do in order to actually deploy it into the networks that we want is that we need to set up a different Hardhat configuration to have access to that network. Now, before we start configuring our Hardhat configuration, I want to take a very quick detour to share a bit of the differences between Web2 architecture and Web3 architecture when it comes to development. If we look at Web2, which is probably what you're most familiar with, you'll see that we have a front-end application, which is what the user is interacting with, and that front-end application interacts with our back-end, usually through some kind of API that is being exposed by being hosted in a cloud provider like, say, AWS, GCP, Heroku, you name it. Now, Web3 works a little bit different. You have a front-end application still, which is what the user is interacting with. But in order for that front-end application to interact with the blockchain, that has to be exposed through some node providers and RPC endpoints. And so you can imagine these node providers and RPC endpoints as really the ones that are exposing and broadcasting your contracts so that front-end applications can leverage it. And in this case, the code, which are the smart contracts, the database, which is that open public ledger, and the execution environment are all provided by the Ethereum virtual machine or the blockchain network that you're leveraging to expose your products. Now, this is important because as we're setting up our Hardhat configuration file, we see that we're going to need two specific environment variables. First, our RPC endpoint API, which is the one that will give us access to, in this case, Infuria, to deploy and broadcast our smart contracts to the network, as well as our private key, which is the private key of the wallet that will be actually deploying those smart contracts. So first, let's get our Infuria API key. If we go ahead into Infuria's website, we'll be able to immediately see a dashboard once you log in that looks similar to this. And what we want to do is first create an API key. We can call it my token, and that'll generate an API key for us. And you want to set it up which specific network you want to have access to with that API key. And it'll give you this endpoint, which you can use immediately with your key so that you can deploy those smart contracts. So of course, we're going to create an environment file where we're going to store that key. Now, the second thing that we need is our private key. Now, for the scope of this video, I'm not going to show you how to get your private key. There's tons of documentation out there online, depending on the wallet that you're using. But I do want to make an important note here that most of the hacks of the recent years have come from developers exposing their private keys to GitHub or publicly. So as you're doing this, definitely do not expose your API key here directly on your file. Make sure that your .env file is part of your gitignore, and ideally even use an additional plugin or package to encrypt this private key as you're leveraging this product. And so with that set up, now we're able to simply run our script npx hardhat run scripts deploy, this time passing it the network Sepolia attribute. And with those environment variables and our deploy script, we should be able to now deploy our contract into Sepolia and see it live. So let's give it a little bit. Yay! All right. So if we go ahead now and hop over go into Sepolia Etherscan, type in the address, and I can now see that our contract has been deployed as an ERC20 contract. Yay! Hopefully that gave you a good rundown of how to build and launch your own first token, leverage OpenZeppelin's contract library so that you can bootstrap your product with battle-tested contracts, and then deploy it, both on your local chain as well as testnet or even mainnet if you're ready for that point. As for next steps, I would definitely recommend writing some tests in Hardhat to keep testing out how the interaction with contracts work, as well as building a front-end application so that you can potentially mint, burn, and pause those contracts directly from a user interface. See you in the next one.